Hello everyone, and welcome to our presentation on density and how it relates to stoichiometry. This presentation is done by me, Rudra, Ethan, and Quinn.
How to calculate density. Density is the given mass for each individual volume and is calculated by dividing mass over volume. How density relates to stoichiometry. You can find the mass or volume when you are given the density and the other piece of information. You can also multiply the volume of a gas by dividing its density to find the mass, or divide the mass by density to find the volume of the gas.
Now we are going to go over a few example problems. The density of oxygen is 1.429 grams per liter. How many liters of oxygen are needed to react with 93.086 grams of fructose? The balanced equation is fructose plus 6O2 becomes 6 carbon dioxide and 6 water. Now please pause the video and try to find the solution yourself. Once you think you have found the solution, play the video again.
So here's the solution for problem 1. You take your 93.086 grams of glucose and use molar mass to convert it from grams of glucose to moles of glucose. Then you use the molar ratio to convert from moles of glucose to moles of oxygen. Next, you use the molar mass again to convert from moles of oxygen to grams of oxygen. And finally, you use the density to convert from grams of oxygen to liters of oxygen, giving you exactly 69.420 liters of oxygen. And for all the doubters out there, this was completely intentional on my part.
The density of H2 is 0.090 grams per liter. How many grams of water are produced when reacting 13 liters of H2 with excess OH? The balanced equation is H2 plus 2OH becomes 2 water. Now please pause the video and try to find the solution yourself. Once you think you have found the solution, play the video again.
Alright, so here's the solution for problem number 2. Here, we take the 13 liters of H2 and use density to convert from liters of H2 to grams of H2. Then we use the molar mass to convert from grams of H2 to moles of H2. Then we use the mole ratio to convert from moles of H2 to moles of H2O. Finally, we use molar mass again to convert from moles of H2O into grams of H2O, giving you an answer of 21 grams of H2O.
AKA, what's 9 plus 10?
21.
You stupid.
The density of water is 1 gram per milliliter, and the density of HCl is 1.18 grams per milliliter. How many liters of water are produced when reacting 5.39 liters of HCl with excess sodium bicarbonate? There is no given balanced equation. Now please pause the video and try to find the solution yourself. Once you think you have found the solution, play the video again.
Okay, here's the solution for problem number 3. You take your 5.39 liters of HCl, then use a conversion factor to convert it from liters of HCl to milliliters of HCl. Then you use density to convert it from milliliters of HCl to grams of HCl. Then you use molar mass to convert it from grams of HCl to moles of HCl. Then you use the mole ratio to convert from moles of HCl to moles of H2O. Then you use molar mass again to convert from moles of H2O to grams of H2O. Then use density again to convert from grams of H2O to milliliters of H2O. Finally, use another conversion factor to convert from milliliters of H2O back to liters of H2O, giving you exactly 3.14 liters of H2O, also known as pi.
For advice and suggestions, remember, tip number 1, always keep track of the units in your equations, and don't forget to round to significant figures at the end. Tip number 2, make sure to write out your equation and balance it if needed. Tip number 3, never memorize specific parts of an equation, only memorize general parts, and then use algebra to find specific parts. Finally, tip number 4, practice makes perfect. So make sure to go online and search up Stoic practice problem worksheets, and you'll find plenty online. Tip number 5, use as much time as you need to study for the test. If you think you need more time, start studying earlier. And finally, review the information before you go to sleep so that the information can soak in before you take the test. Thank you, and good luck for finals.